Hi again. Uh, Today I'm going to show you how to conduct 4 more tests to test whether there is a structural break in the time series data or not. In my previous videos, I had shown you how to conduct 3 tests for this purpose, and that was Perron breakpoint unit root test, Chow test, and the Kusum test in eViews. Today I'm going to show you 4 more, and they are the Kusum of squares test, by Perron test, a Zivot Andrews test, and the Quant Andrews test in eViews. Having said this, the key assumption here, unlike in the Chow test, is that we do not know the date, which is the month, quarter, or year of, uh, sorry, of, we do not know the date, that is the month, quarter, or year, when this break occurred. These tests will show us when these breaks occurred. Whereas in the Chow test, we already knew from beforehand that there is a structural break in this particular year, month, etc. So, having said this, now I'm going to show you how to use 4 tests for this purpose in eViews, uh, and I'm using quarterly data on US consumer spending, and that's the first variable, and the other is this variable here, disposable income. What I've done initially is that I've done a transformation of the data, which which is something one needs to do in time series data. I've done the a logarithmic transformation. So I'm going to go to eViews. I have the consumer spending termed as RHFCE here, and the second variable is RPDI. What I've done is I have first transformed them, both these variables, a logarithmic transformation. So I'm going to click on View Spreadsheet. This is the formula to to transform consumer spending and the second variable, disposable income, into a logs. But out here I've shown you consumer spending, how I've transformed it. This is, and in one of my previous videos, I think it was the second video or the first one, I had shown you exactly how to do this transformation by choosing the quick option and generate series. So I am not going to again carry this out. You can easily go and view, you can easily go and see that, right? So having said that, here is the series. The second step after the log transformation is that you graph the data. I'm graphing it. This is the tab. You don't have to do anything. Just click on OK simply. Okay. Now, just by visual inspection, it seems that there are one, two, that is 2008, and we know why. And third is the pandemic, 2020. So there is more than one structural break upon visual inspection, but we must go in for these tests, because if you don't get this right, a structural breaks, you are going to go totally totally wrong. So it's very important to know that how to conduct these tests, so that you know when there has been a structural break in the data. Okay. Having said that, now what I'm going to do is that I'm going to go and show you the first test, which is the Zivot-Andrews test, which assumes that we do not know the date of the structural break. And this test is designed for detecting a single unknown structural break in a time series data. So this test will identify for you what is the date of the structural break. In this case, it is quarterly data, so we have to find out when did the break take place. Okay, so this is the data. Out of all these options here, you go to add-ins. Here is the test. An important point to note is that you have to download this test from this download add-ins. That's what I've done, that's what I do. And then you go on and here is the test. You just click on the test. Here you have three options. Is there a break in the intercept, trend, or both? Visual inspection shows me that there is a break in both. Now, if you were to view, now this is something very important. If you were to view one of my previous videos, I think it was the second or the third one, there you actually, I show you how to know whether there is a structural break in the intercept, a structural break in the trend, or there's a structural break in both. And this is something, it's a foundational thing, because if you go wrong here, you could go really wrong. And thing is, you would go wrong. So I would really request you to go and view that video where I've shown this. Having said that, now out of these options, I'm going to choose both. Then what I'm going to do is I'm going to select 4 lags, as this is quarterly data. Okay. So after which I'm going to click OK. And here we have the Zivot-Andrews unit root test. It shows that the chosen breakpoint is 97 quarter 3. Now, why this structural break occurred is something one can then investigate. Why? Was it due to a war? Was it due to a pandemic? Was it due to a change? I mean, was it due to any other reason? And the reasons I have stated here is that example could be, you know, some of these reasons that I have like mentioned here is something for you to actually ferret it out. So I'm going to, so this is 1997 quarter 3. The problem with this test is, and this is something important to note, is that it just takes into account and finds out whether there is one structural break which is unknown, whereas when we had viewed the data, we could easily see that there is more than one structural break. So in this case, it's important to note that you should use this test when you know, upon visual inspection, you infer that there may be one structural break in the data and not more, because clearly this is inadequate. You have one, but you have others also, as we had viewed from the consumer spending data. But it's important to use this if you feel there is only one structural break. Now, having said that, the chosen breakpoint here is 97 quarter 3. And here the Zivot-Andrews test statistics is -69, which is less negative than -5.08. And here the probability value is greater than 0.05, which means that the series has a unit root. It is non-stationary. So we cannot reject the null hypothesis that consumer spending has a unit root with a structural break in both. So this is the first test. Yeah. Now I'm going to go, let's go back to the Word file. I'm going to now show you the second test, that is the QSUM of squares test. We've done the first one. Now we take the second one. Through this test indicates whether whether the econometric model we are going to build for this test and these two, that is for these three tests, whether the model is stable and whether there is a structural break or not. Now, importantly, this test doesn't show you the dates, but it clearly gives you an indication whether there is a structural break in the data or not, and this is exactly what I'm going to show you now. So we are going to go and perform the Kussumov squares test now. So I am going to now go here. Simply I'm going to shorten the sample size. Just like before that, I've just forgot to mention, in this particular Zivot Andrews unit root test, note that one should take the entire sample of the data to conduct this test, entire range. Okay. Next, I'm going to now show you the this test, Kussumov a squares test. So I'm going to go to sample. What I'm going to do is I will clearly oops, sorry, 1983 quarter 3, then I'm going to type in 2023 quarter 3. I'm sorry, I'm going to shorten the sample, right? Okay, 97. Now we have 25 years of data. That's 1997 quarter 3 to 2023 quarter 3. Those are 25 years. Yeah. Having done that, I'm going to now go to these options here, go to quick. I'm going to estimate an equation, that is ln. This is the dependent variable, and then this is the disposable income is the independent variable, and we click on OK. Here it is. Yeah, okay, this is the one. Now, having viewed this, I'm going to go to view. Then out of all these options, I'm going to choose, go down, recursive estimates OLS only. Having done that, I'm going to choose the third option. That's it. Nothing else is to be done. Then you click here. And now I'm going to put this very simply, not going into detailed explanations. This blue line, you see this portion here, it is beyond the 5% significance band. When this is beyond the 5% significance band, it shows two things: that the model that we have built is not stable, and the other is this is clearly an indication of structural break. So when this blue line crosses this band, either here or out here, this is clearly indicative that there is a structural break in the data, there is a structural break in the model. So this test will not show you exactly the unknown where the break has taken place, but it gives an indication that there is a structural break in the data. Having said that, now I'm going to conduct. So this is the second test, which gives you an indication. So this indicates clearly that there is a structural break, but it does not tell us when did the break take place and whether there is more than one structural break or not. But this is a very useful test because it immediately tells me that there is a structural break. Now, following which I'm going to now choose the Quant Andrews test, which is the third one, where again we assume that we do not know the date of the structural break, and this test is designed for detecting a single unknown structural break in a time series data set. So I'm going to go here again. I'm going to press the estimate button. Here you have again 97 quarter 3. This is 25 years of quarterly data. Here you are, and this is it. This is exactly the same model as we done like before. View, you go to view, and then you go to stability diagnostics, and then quant stability, sorry, go to view, then go on and choose this option of stability diagnostics. Then you go on and do the quant Andrews breakpoint test. Okay, here you don't have to do a thing, but this something I'm coming to is very important. If a data set, the presence of outliers is really distorting the data, and like for example in the case of oil or some highly volatile data, or in some data set there are these outliers which are totally distorting it, then then it's preferable to keep this exactly as 15% trimming percentage. But if the data, the presence of outliers is not much of an issue or not a real issue, then I would choose the 5% one. Or if you want to play it safe, where it's not too much, the presence of outliers is too, it's not really an issue, it's not really distorting, but it is having some impact, then you could choose the middle path, that is 10%, that is trimming percentage 10. Now consumer spending data tends to be relatively stable data. So for relatively stable data over time, I would prefer the 5% one. Okay. Then note the default was 15% and I've chosen 5%. Now this is a matter of judgment for which you actually first view it visually, view the series, and then after which this is what you got to choose. So I'm going to click on OK. Right. Okay. 1 second, please. Okay. Yeah. Sorry. Digital diagnostic quant Andrews test. This is, I've chosen 5% here, and I click on OK. There. Now we all know that in the pandemic was a time where there was a where there was a where there was a structural break in the data. Upon visual inspection and seeing through the series, I know that what this is saying is absolutely appropriate and right. But again, like the first test, a Zivot Andrews test, the problem here is that this test is again for detecting for detecting only one point, unknown breakpoint. That's only one a structural break. What about the structural break in 2008? We know why it happened, and there seems to be one more. So again, use this test when you believe that in the data there is not more than one structural break. There is only one, and there is where you can use this test to view where is the structural break taking place, that is 2020 quarter 2. So this is your third test. Now I'm going to go to the most important test, that is the Bai-Perron test here, that is the fourth one, where the sample size should be at least 100 data points. And unlike the Chow test, we do not know from beforehand the date, that is the month, quarter or year of the structural break. And we use this test when we suspect that there is more than one structural break in the data, and when we are unable to easily explain the cause of a structural break. Sometimes what happens is that there are certain structural breaks in the data which you are not aware of or why it occurred. Okay. For example, we know that there is a structural break in the data due to the pandemic, and in 2008 due to this. Then you have other reasons, but in this case there are breaks in the data which you don't know why it happened. So this is a test which is very useful for that purpose. Of course, it will also show you the structural breaks due to the pandemic, or in 2008. But sometimes, as I said, we don't know that there are these breaks in the data. So for which we should use this test, and because we don't know the reason to. So so thing is, we are unable to easily explain the cause of the break. Okay, so when we are unable to explain easily the cause of the break, then this test is very useful. And upon visual inspection, when you feel that there is more than one, then actually this test really turns out to be the option for you. So I'm going to go back into eViews here again. I'm going to go to estimate, same thing, 97 to 2023, that is 25 years. Click on OK. Then I will go to view. I will go to view stability diagnostics and choose the multiple break even, that is this last test known as multiple breakpoint test. We already know from the visual inspection that there is more than one, so this is the appropriate test to use. Now again, here you leave this unchanged. I'm going to leave this unchanged. Maximum breaks, it says 5, unchanged. There are two things I'm going to change. This as I had stated before in those in a previous test, if the presence of outliers is not really an issue, which doesn't seem to be the case here, I'm going to choose 5%. I'm going to choose 5% as trimming percentage. You can, for safe side, use 10 also in this case, but it depends, as I stated before, on the nature or the characteristic of the data. The presence of outliers is not really too much of an issue here, or when it's not issue, then you use 5%. Significance level, keep this unchanged. This is all unchanged. And now this is important to note: allow error distributions to differ across breaks. So you must do this. You must select this option and then click on OK. There you have. There you are. It says that this data has 5 structural breaks. Now sequential F determined breaks 5, and the break dates are 2020 quarter 2, 2008 quarter 2. Here these are the 5. Now 2020, we know it was the pandemic. 2008 quarter 2 also, we know and we know why. GFC, GFC, due to GFC. Then here we don't know why they occur. Now, having stated this, there is a problem with this test. It shows that there are 5 structural breaks. This is where you need to be very careful, because what happens is, I'm just going to go to the Word file and I will explain this very simply. The econometric model that I've made, if it suffers from the problem of serial correlation, that is, if the econometric model, there is serial correlation in it, then that may cause the test to detect structural breaks that do not even exist, which means there could actually be 3 breaks in the data, but it's showing 5. There could be 3 breaks in the data, it could be showing 4. Or if you take another time series like data set, there could be 2 breaks, and this test shows that there are 4 breaks. So in this case, what you must first do is, after you get this output for the first time, what is important to do is that one second here, once you get this output, This is the first output of the test. Then you again go and you estimate the equation here again. Okay, just estimate it again after you get the first output. Okay, now you have this same model in front of you. Okay, so go to view, and then from view uh, go on to residual uh, go on to residual diagnostics, not stability diagnostics but residual diagnostics, and click on serial correlation LM test, because we are trying to find out whether this model suffers from serial correlation or not. If it does, which means that this test is showing us more breaks than actually there are in the model. Okay, uh, following which the lags that I'm going to include are 4. Okay, structural break here. Now you see this value here, P is less than 0.05, which is indicative that this model P is less than 0.05, which is indicative of the fact that this model suffers from serial correlation, and we cannot and this null hypothesis is that there is no serial correlation at up to 4 lags. But since P is less than 0.05, reject the null hypothesis. There is serial correlation in this model. So having said that, I'm going to again get the model back, and I'm going to go to view, and following which I'll go back to stability diagnostics, following which I will go to the third option again. Here again I will leave this unchanged, and I'm going to, because of the nature of the data, consumer spending is fairly like stable, and from whatever I could view from the data and from the whatever I could view from the data, the trimming percentage that I choose is 5%. Now here what I'm going to do is, since this model suffers from serial correlation, what you need to do is you need to reduce the maximum number of breaks that this data can actually this particular test can show. So you can choose the option of 2, or you can choose the option of 3. I'm going to choose 3 because upon visual inspection it seemed that there are 3, though I don't know the dates. So I'm going to so what I'm going to do is I'm going to input 3 as the maximum breaks. So this is what you do when there is serial correlation in the model. This test is likely to show that there are more structural breaks than there actually are. So what you've got to do is you have got to test the model for so then you've got to test the model, which we have just done. Since there is serial correlation, I'm going to reduce the number of maximum breakpoints that this test can detect, which are unknown to me. So from the maximum breaks option of 5, I've chosen 3. Yeah, you can also choose 2, but upon visual inspection and seeing the data, I suppose there are 3. So I'm going to again click on this, and here is where the test comes. Yeah. So now this test shows that there are 3 breaks in the data here. 3. And if we go down, the break dates are 2020 Q2 pandemic time, GFC time is 2008 Q2, and 2013 Q1. Now one of the tests had also shown us as 2020 Q2, which from the data is evident. Okay. Now I don't know why this structural break happened, this unexpected something which I could not view, but this test was able to detect the break in the data. So Byparon test is very useful because it helps to detect structural breaks, and we may not know that there is a break here just by visual inspection. Though in the case of pandemic, one could easily see from the data that there is a break, but 2013 quarter one, no. And 2008 quarter two also, one was aware of it, but if someone does not know that in 2008 the GFC was going on, so this is 2008 quarter two and 2013 quarter one, right? So these are the three points of a structural break in this data. In this, in sorry, there are three breaks which have been shown by this particular test, and now we must deal with these breaks, because if you don't deal with these breaks, the model is going to, of course, be wrong. That is something I will leave at for another video. So having shown these four tests, I'm going to go back again to the Word document here, and in my conclusion, what I have stated here is that you should perform more than one structural break test and consider the results collectively or together. Further, plot the data, visually inspect for breaks, which can provide valuable insights vis-a-vis when structural breaks in data might have appeared. You may not know the date, or thing is, you may not know the cause. So this is all that I have to say, and I hope that I've been able to explain these four tests in these videos easily, and that you have been able to comprehend whatever I have said. Now this is actually my final video on these tests, which are a total of 4 today plus 3 in the previous videos. That is a total of 7 tests for this particular purpose. Thank you very much.